All right, today we're going on a bit of a different kind of tour. We're heading to some of the absolute most extreme, most terrifying places in the entire universe. We're going to find out what would happen if you somehow ended up in the worst spots imaginable. So yeah, let's kick off our tour of cosmic peril.
So what's the most terrifying way to die out there in the cosmos? I mean, it's a pretty grim thought, but you can't deny it's also kind of fascinating, right? Are we talking about unimaginable heat, or maybe being crushed by gravity? Or is it something weirder? We're about to explore 5 of the most epic, most explosive ways the universe could just, well, end you.
So you might want to buckle up. Our tour of doom is officially starting now. We're going to visit the living tombstones of giant stars, check out some intergalactic smash-ups, and even witness the universe's ultimate fireworks. And believe it or not, our first stop is surprisingly close to home.
Yep, that's right. Our tour begins at the galactic inferno next door, the star we see every single day, our sun. From a cool 150 million kilometers away, sure, it feels like life-giving warmth. But get up close? Oh, that is a completely different story.
The surface temperature of the sun is about 5,500 degrees Celsius. Now, to put that in perspective, that is hot enough to boil diamonds. I mean, just let that sink in. The hardest thing we know of, just poof, boiling away. And get this, that's just the cool part, the very surface.
So forget any ideas about landing on the sun. It's not a solid place. What we see as its surface, the photosphere, it's really just this chaotic, violent layer of boiling plasma. Imagine trying to land on a soup made of lava, except it's infinitely hotter and way, way more angry. So if you were to magically appear there, your end would be, well, basically instant. We're talking milliseconds. In just 1/10 of a millisecond, your suit is just gone, your visor belts away. Less than half a millisecond later, a shockwave of that boiling plasma just slams into you, and by the time 10 milliseconds have passed, it's all over. Your flesh, your bones, everything is turned into gas. You literally wouldn't even have time for your brain to register what's happening. You're just gone. Part of the sun now.
Okay, for stop number 2, we're leaving the inferno behind. The threat here isn't heat, it's gravity. We're jumping 1,500 light-years away to a black hole called Gaia BH1. This is where gravity gets so extreme it basically breaks the rules of physics as we know them.
Stellar mass black holes like this one have been called the living tombstones of giants. And honestly, that's the perfect description. This isn't just some random object floating in space. It's what's left after a truly massive star collapses under its own weight. It's, quite literally, the ghost of a giant.
And this brings us to one of the most wonderfully terrifying words in all of science, spaghettification. It sounds silly, but it's exactly what it sounds like. It's the process where gravity gets so intense that it pulls on, say, your feet way more than it pulls on your head. The result? You get stretched out like spaghetti.
Let's walk through it. As you fall feet first towards the black hole, the gravity pulling on your feet is just exponentially stronger than the gravity at your head, so you start to stretch. At the same time, the forces are squeezing you from the sides. Your spine, your bones, they crack and elongate. And eventually, you're just torn apart, atom by atom, becoming a stream of particles flowing into the singularity.
But here's where things get really weird. From your perspective, you just keep falling, feeling that insane pull get stronger and stronger. But for anyone watching you from a safe distance, thanks to Einstein's theory of relativity, you would actually appear to slow down as you get closer to the event horizon. Eventually, you look like you're just frozen, stuck in time, forever, right on the edge of nothingness. Wild, right?
All right, on to stop number 3. We're headed to something that's almost as dense as a black hole, but it comes with a few extra, deadly features. This is RxJ 185635-3754, the closest neutron star to us. To really get why a neutron star is so dangerous, you have to wrap your head around its density. The gravity here is so intense that atoms themselves are just crushed. A single teaspoon of stuff from this star would weigh, wait for it, 1 billion tons. Yeah, it is one of the densest things in the entire universe. And see, unlike a black hole, which kind of just has the one trick, a neutron star is a multi-pronged attack. First, its magnetic field is so powerful it would instantly fry any electronics you have. Then, you're hit with the flood of X-rays and gamma rays that literally destroy your cells. Then there's the extreme gravity, which, spaghettifies you, just like a black hole.
And if, by some miracle, you survived all that, you'd slam into a surface that is 10 billion times stronger than steel. So, no chance.
So what's the end result of all that? Well, that crazy gravitational pull would stretch you out over miles. I love this description. In one moment, you are a person, and in the next, you are miles of silly string. A pretty vivid and final image, isn't it?
Okay, so far we focused on dying on single objects. Let's scale things up a bit. For our fourth stop, we're traveling billions of light years away to a place called El Gordo. And what is El Gordo? It's a cosmic furnace created by the collision of two entire clusters of galaxies.
I mean, just try to picture that. What happens when literally thousands of galaxies get into an intergalactic smash-up derby? We're not talking about one star hitting another. We're talking thousands of galaxies, each with billions of their own stars, all crashing into each other over millions of years. The result is one of the hottest, most violent places we've ever found.
And the temperature inside this cosmic pileup is a staggering 160 million Kelvin. Just for comparison, the core of our own sun is only about 15 million. So, yeah. This place is an environment of pure, unimaginable heat.
So what would happen if you flew a ship into El Gordo? Well, first, you'd slam into a cosmic shock front moving at thousands of kilometers a second. Your ship would be shattered instantly. Then, you're exposed to space, where you're immediately hit by a wall of pure heat and radiation. You wouldn't just burn. You would boil, you'd vaporize, and your atoms would be ionized in less than a second.
And now for our grand finale. We're not just visiting a place this time, we are witnessing an event. This is a supernova, and not just any supernova. This is SN 2016 APS, the brightest, most powerful one we have ever seen. It was probably caused by two huge stars merging right before they exploded.
This chart really puts it into perspective. At its peak, this one explosion was 100 billion times brighter than our sun. That's as bright as our entire Milky Way galaxy, with all its hundreds of billions of stars. But all that energy is concentrated in one single catastrophic event. Being anywhere near this thing, it's just not an option.
Your end here would be total and, again, basically instantaneous. In the very first millisecond, a torrent of invisible particles called neutrinos would just flood your body, rupturing your cells from the inside out. A few milliseconds later, the actual shock wave hits you, shredding you completely. By the time 10 milliseconds have passed, you're gone. Your atoms are just swept away in a ball of scorching, expanding plasma. The end.
So there you have it. From the boiling plasma of the sun, to the bizarre stretching of spaghettification, to the absolute, total obliteration in a supernova, these are some of the universe's most extreme ways to go.
But you know, this whole tour of cosmic peril really just highlights the incredible power and, honestly, the wonder of the cosmos. It really makes you think, right? So, where should our next tour of exploration take us? What other cosmic mysteries, whether they're creative or destructive, are out there just waiting for us to discover? Thanks for joining me on this rather grim tour